Okay, good evening, everyone. Welcome to O-Level Physics lesson. My name is Mr. Chu. Today is Tuesday, 28th of June, and we'll be going through some structured question on practical electricity. Okay, as a revision, all of you have given me the answer already. The two formula you need to know before this topic. Okay, before this topic is power is equal to energy over time. Then you rearrange, you make energy as the subject, you get power over power times time. Okay, the second formula that you need to know before this topic is V is equal to IR or RI. Okay, so these are the two formulas that you need to know prior to this topic. Okay, so what are the formulas that you will learn in this topic? Only one formula. The only formula you need to know in this topic is P is equal to VI. Okay, and from these three formula, you can expand it to 6 formula. Is that clear? So for example, if my V is to change my V to IR, okay, I will get I square R. Okay, likewise, if I change my I to V over R, I will get V square over R. Is that clear? Okay, same thing. Energy is power times time. So basically, you just copy everything above, you add a time to it. So VI times T. Okay, I square R times T. The last one, V square T over R. Okay, so the second row formula, you look at this E, your P, just replace the P in this formula. So basically, all my underline are my P. Okay, these are my P. Is that clear? These are my P. Okay, so you just need to add a T after that because energy is equal to PT. So you use the formula on top, you add a T at the end. Is that clear? Okay, Beikwan, the formula I wanted you to tell me is this formula. Can you write down this formula and show it to me? Energy is equal to VI times T. Okay, Beikwan, can you do that now? Okay, I'm going to start the first question. Okay, wait. Where's my first question? Hold on. Okay, I'm going to share the first question. Okay, so everybody start doing question number 8. A, 1, 2, 3. Okay, can all of you do that now? Every one of you? Okay, does everybody know what's the meaning of efficiency? Okay, Ryan, well done. Instead of saying total power use, you can also say total input power. Okay, input. or total power input. Okay, let me write down the first question first. I've not talked about efficiency to you. Okay, if efficiency is a formula, that is the ratio of the amount of useful power output, okay, to the total power input. Is that clear? Okay, so for example, this efficiency thing is useful to determine whether is your machine working efficiently. If this efficiency is very low, maybe 10%. Okay, what does it mean is that you are actually wasting 90% of the power or energy. Is that clear? Okay, so everybody give me your answer for part 1, then do question 2 and 3 for me. Yuting of part 1 is correct, well done. Okay, Yuting, your part 2 is correct, very good. Oscar, your part 1 is correct. Bei Kuan, your part 1 is correct. Okay, all of you do part 2 and 3 quickly. Hey, today I got a feeling that you all are very lethargic. Are you all okay or not? Okay, Yuting is giving me part 3 answer already. The rest of you have not even given me part 2 answer. Okay, Yuting, your part 3 is correct. Well done. Okay, Yuting, you're going to take a short break. It seems like the rest of them long time never go to school, right? They now go back to school. They're very tired now. How Ray? Why do you say 10 times? That's not the correct. That's not the correct working. Your answer is correct, but working is wrong. Bei Kuan, your part 2, you did not put in your unit. Remember, we have have a habit of writing down unit. Okay, the question here is, Which of the lamp produce a greater useful output? Okay, greater useful output. So you're supposed to go and calculate the output power. Is that clear? Okay, go and calculate the useful outward power. Okay, Pei Kwan better now. Your significant figure is also not accurate, Pei Kwan. Okay, so what is the output power for both? Hello, the rest of you. Where are you? Where are you? Okay, Oscar, your part 3 is correct, but where is your working? Ryan, your answer is correct for part 2, but where's your working? How do you get the answer? Hello, where are all of you? Okay, so you multiply these two together. Okay, you should get the answer. Okay, 9% times 40, you'll get 3.6 watts of output power. 40% times 10, you'll get 4.0 watt of output power. Okay, so from here you can tell that the greater useful output power will be this number. Okay, so the answer for this will be compact fluorescent lamp. Okay, so can you all please put it down in working plus words? Okay, so the difference in input power is 30 watt, which is 0.03 kilowatt. Clear? The difference is 0.03 kilowatt. So the energy used is equal to power times time. In this case, the power is 0.02 kilowatt. The time is 600 hours. So therefore, what is the what is the energy use? Okay, 0.02 times 600. You will use the difference. Okay, the difference in the energy use is 12 kilowatt hour. Okay, I'm calculating the difference between the two. Okay, so if you use filament lamp, you will always use 30 watt more than the compact fluorescent lamp because the difference is 30. Okay, so my working here is wrong. So it's 0.03. Okay, so it's not 12 kilowatt hour, it's 18 kilowatt hour. And each kilowatt hour is 25 cents. How much would 18 kilowatt hour cost? Okay, so after calculating, you should all get 450. Okay, so if you want to switch to a compact fluorescent lamp, because it uses 1/4 of the electrical power, and you end up saving 450 every year. Okay, this might not look like a very big saving. Okay, it may not look like a big saving. But can you see how much less energy you use? Okay, it actually uses 4 times less energy. Is that clear? So this number is 3 times more than the others. Sorry, it's 4 times more than the other. The difference is 3 times. Okay, so basically, if you use a compact fluorescent lamp, you only pay 150 for the lights for 1 year. But if you were to use fluorescent lamp, you actually pay $6. So now, from the context, do you think that you save quite a bit? Instead of $6, you are just paying 150 every year if you were to use this fluorescent lamp for 600 hours every year. Okay, 600 hours is about 1.5 hours a day. Clear? Okay, if you are clear about this, can I see your answer? Okay, I see that today you are quite slack. If you are okay, can you please type out the answer and show me? Okay, if you are okay, give me a thumbs up. Okay, if you are okay, give me a thumbs up. I can tell you at the rate that you are participating, you will not be gaining much out of this lesson. Okay, and then we are just a few short months to your O levels, and I am starting to worry because you all tell me that you are still not doing well, and yet when I'm here to help you, you are not participating. So do you want me to be like a fierce teacher and to scare you all into doing things? You also don't want, right? So can you all please? Okay, it's only a few months left. And if you need help, Okay, please ask me. Okay, please ask me. Okay, let's do part 2. Okay, part 2, are you able to do? Okay, we'll skip part 2. This one is under electromagnetic spectrum. Okay, we will not go through that. Okay, you all can try yourself. This is a 2014 question for question 8. Okay, part B, you all will go and do yourself. Let me go and skip the next question, 2017. Okay, all of you now do question A and B. Okay, do A, B, and C. Okay, all of you do that now. Okay, Oscar, well done for part A. Ryan, well done. Hao Ray, well done. Xiao Xing, well done. Yuting, your A number 2, right? Can you elaborate? Okay, can you elaborate your number 2 point for your A? Okay, I'll only give you 1 mark. Okay, Yuting, your B1 correct. Well done. Bei Kwan, your A number 2, I will not give you the mark. Ryan, for your part B1, your answer is correct, but can you write down your answer is correct to how many significant figures? Ryan, incorrect for part 1, B part 1. you need to correct to the correct significant figure. Okay, Yiting now is a bit better now for your number 2. Chelsea, your answer is for part B, is it? Okay, you didn't write down the working, so I would not know. Okay, but you're correct, Chelsea. Okay, Ryan, is your answer for your last answer? Is it for part B2? If it's for B2, your answer is wrong. Okay, Oscar, your part B2 is correct. Okay, Ryan, yes, your last question is not correct. Chelsea, your part 2 is correct. Well done, well done. Okay, let me give you some of the answer for part A. There are a lot of answer, okay? There's a lot of answer. Earth wire connected to metal casing. Okay, that's number 1. Okay, other thing that you can talk about will be circuit breaker. Okay, you can also talk about switches on the live wire. You also can talk about double insulation. So any of these 2 out of the 4 for part A, you'll get it correct. Because we did not learn surge protector in your O level. Okay, so for part B, power is equal to VI. We just plug in P over V. Your power in this case is 800 watt. Your voltage is 230 volt. Okay, so use your calculator. Okay, you should get the answer of 3.5 ampere to 2 significant figure. Yeah. Then, because your current will be operating at 2.5 ampere, there are 3 different fuses available. 3 ampere, 5 ampere, and 30 ampere fuse. So which is the most suitable of the fuse for these appliances? Okay, answer will be 5 ampere. Okay, the reason is because if you use a 3 ampere fuse, if the current is 3.5 ampere, it will actually burn the fuse. Then the whole thing will not work. Okay, if you use a 13 ampere fuse, it is much higher rating compared to the working current of 3.5 ampere. So it's actually of not much protection. So 5 ampere will be just nice, not too much above this. All right, you're talking about your part B, is it? I want you to write down this one, 2SF. Okay, 2SF. That is what is missing for your answer. Okay, you did not write down this answer, 2SF. Clear so far? All of you? Then you give me, Ryan, give me 3.0. I thought you're telling me the last question. Okay, let's go to the next question. Okay, all of you now do question 7, A and B first. Okay, do question 7A and wow, so many questions here. Okay, do these two questions first.
I'm just hoping I'll find.
Who is singing? Okay, Pei Kwan, your part A is correct. Ryan, part A correct. Oscar, Hao Rui, your part A is correct. Xiaoxing, you're supposed to talk about other, one other. Okay, so Xiaoxing for A is wrong. Huh? Yiting, your A is correct. Well done. Okay, Xiaoxing correct now for A. Well done. Yiting, your B1 is correct. Oscar, your B1 is correct, but why no working one? Yiting, your B1 number 2 is correct as well. Well done. Okay, so what are the other renewable energy that you learned before? Okay, so all of you have given me this answer, so well done. Oscar, your part 2, your question 2 is correct as well. Well done. Okay, beside wind energy, what other energy have you learned? You know, like water dam. Okay, water dam, hydroelectric energy. You don't really find that in Singapore, but in some big countries where they have big rivers, they actually have a dam to actually harness the power of a flowing river. Okay, so this could be the possible answer. Okay, so for you, you actually decided to invest in solar cell. It cost you $6,000. So how long does it take, okay, for you to break even? Okay, how long will it take for you to break even? Okay, Oscar, your part B1 is correct. Well done. And your B2 is correct as well, but well done. Pei Kwan, your B1 is correct. Very good. Hao Rui, well done for part 1. Well done. It seems like all of you has no problem doing this. Okay, so for break even, you must calculate energy. Okay, energy is okay, you need to calculate $6,000 divided by 0.26. So how much energy must you generate to break even for this? Okay, so you need about 23077 kilowatt hour. Okay, so you need about 23077 kilowatt hour. And you know that every year it uses 1500 kilowatt hour. So you calculate how many years does it take to generate 23,000 kilowatt hours. Okay, after you calculate, okay, most of you should be able to get 15.4 years. Is that clear? Okay, that should be your answer. And then one assumption you have to make in your calculation. What's the one assumption? Okay, the one assumption you make is the energy output over the years remains the same at 1500 kilowatt hour. Clear? Okay. Oh, okay. So let me continue to the next page. Okay, not next page. Let's do the second one. The efficiency of the solar cell use is 15%. Okay, so now can you calculate part 2? Okay, calculate part 2 now. So the question now is this: how much solar energy do you need to generate 1500 kilowatt hours? Okay. Pei Kwan, your B2 is correct. Well done. Well done. Okay, Chelsea incorrect. Chelsea incorrect. Oscar, well done. Hao Rui, well done. Oscar, do you think that the solar panel will produce sound? Okay, you think your number 1 is correct? Yeah, Oscar, now that is actually more correct. Then don't use the word heat, use the another word. Yu Ting, your question 2 is correct. Well done. Well done, Pei Guan, for part Question 2. Oscar, well done. Okay. Can I have Oscar, can you do question 1 onto the screen? Yiting, can you write question 2 onto the screen as well? How Ray, don't use the word heat. Choose another word. Okay, Yiting has written down the answer below here. So well done for both of them. I'll give you 1 minute to actually write down and to take note of the answers. Well done. Okay, thermal energy is a proper way to use. Okay, for O level, do not use heat energy. Okay, just like your voltage, right? Do not use the word voltage, use potential difference. Okay, same thing. Don't use heat energy from now on. Use thermal energy. Okay, let's do the next question. Okay, so can you all remember this picture, this diagram? Okay, there's an electric current flowing downward in each rod. Current will be from plus to minus. So current go down to each rod. Is that clear? Okay, so let's do the question now. Okay, so start doing. I will sketch the diagram, okay, onto the screen. Okay, so this is the circuit diagram. So can all of you do B part 1 and part 2 for this question? Can you start doing now? Okay, Ryan, your answer is correct for 1. Bei Kwan, your 1 is incorrect. I'll try again. You must remember, Bei Kwan, the 12 voltage doesn't apply throughout the whole of this resistor. Liu Yuting, your 1 is correct. Well done. Okay, Ryan, your part 2 is correct. I'm very happy with Ryan's participation today. Oscar incorrect. Yiting, your number 2 is correct as well. Well done. Anybody facing a problem with part 1? Anybody facing a problem in part 1? Okay. I got one person that asked for help. How about the rest of you? Okay, can Bei Kwan, can you look here? These two resistant rod has an equal resistance of 1 ohm. So are you convinced that each of these will have a current of 3 ampere going through? Can? And then you know that you have the current, you have the resistance. Can you find the V? Okay, so it's 3 times 1. Your V is 3 volt. So if I were to put a voltmeter here, it will show me 3 volt. Clear? So the entire circuit is run by 12 volt. This part is 3 volt. So the remaining part here, if I were to put a voltmeter across the arrow, okay, it will actually shows 9 volt. Clear so far? Because this point here is just 3 volt, the remainder is 9 volt. Can you see that? Oscar, well done. Hey, Bei Kwan, can you move from here? Okay, Bei Kwan, are you able to do now? Well done, Bei Kwan. Okay, so from here, can you find the resistance of error? Okay, so the resistance is V over I, correct? You know the V is 9, your I is 6, and therefore you should get 1.5 ampere. Okay, sorry, 1.5 ohm. Okay, so it's 1.5 ohm. Okay, so what is the one advantage? Let me just give you the answer. I think all of you know the answer for this. Okay, so what's the advantage of this? A circuit breaker can be reset easily by flipping the switch. Unlike a fuse, which has to be replaced when fused. Is that clear? Okay, so for a circuit breaker, you can reset easily by flipping the switch. Whereas a fuse, you need to replace it when it actually burns. Is that clear? All right, let me go through the next question. Okay, do question A and B1 first.
Okay, shoot.
Okay, 北关 don't use the word reusable. You can use it. You can use the word can be reset easily. Okay, don't use the word reusable. So everybody now explain why wire A rather than wire B is connected to the live. Okay, so quite simple, right? Why wire A is connected to the live? Because you're talking about so that less of the circuit is charged. What are you referring to? Oscar, your way of explanation is wrong. If your switch is off, there'll be no current. Okay, there'll be no current. So can you think of how to rephrase your answer? You all slow down already. Like. Where are all of your answers? Don't slow down. Eh? Okay. Today, Yi Ting has always been one of the first to answer. I'm very happy with your performance. Some of you are just not replying. Okay, Yi Ting, for part A, I will not give you the correct answer. Sorry, I'll not give you the correct marks. Okay, can you try again for part A? Okay, Yi Ting, your B part 1, I'll give you the marks. Well done. Your B part 1, I'll give you 3 marks. How Ray, even if the switch is at the neutral wire, if the switch is off, there will be no current. Okay, I want you to take note. I already read that from Hao Ray and Oscar. What have you mentioned that if the switch is at the neutral wire, even if switch is off, there will be current. That is incorrect. Okay, that's incorrect. Okay, so let me explain to you the concept. Okay, then you tell me what you understand. Okay, so let me have the okay, so I put a switch before the bulb and a switch after the bulb. So the switch is at the live wire and the switch is at the neutral wire. Okay, so even if both the switch are open, there will be no current. Is that clear? There will be no current. Okay, if I were to close this switch, there also will have no current because the circuit is open, no current will flow through. Okay, so from what I'm reading from Hao Ray and Oscar, you tell me that even when the switch is at the neutral wire and it's open, there will be still current in the circuit. Okay, that explanation is incorrect. There will be no current at all because the circuit is open. Is that clear? There will be no current at all because the circuit is open. So what happened if I put the switch at the neutral? What happened? Okay, what happened is this. Live wire may have a voltage of a potential of 230. Even if there is no current flowing through it. Okay, if there's no current flowing through it, let me use green color. The point here all the way to the switch, all this green point will also have a potential of 230 volt. But that doesn't mean that there is current because there's an open circuit, there will be no current. But all the green part of the circuit will have the potential, high potential of 230 volt. Is that clear? Are you clear about this now? Okay, so what happened? Let me explain a bit more. Okay, so if I were to put if I were to close this circuit here, okay, close. Same thing, the live wire is still 230 volt. However, what is happening will be this 230 potential will be still all the way to the start of the switch. So for the bulb After that, from the one end of the switch all the way to neutral, okay, all these part that I did not highlight will be 0 volt. Is that clear? So if you touch the bulb, you will not get shocked. But if this green color part is all the way to the other end, your bulb has a potential of 230 volt. There's no current. But when your hand go and touch it, what happened? There will be a difference in potential. Current will flow through you. Okay, so how do you explain this? Yeah, I hope I make it clear in my explanation. So are you clear about this? So let me write down. Okay, let me read How Ray's answer. Okay, How Ray, can you rephrase it? Your live wire will no longer be connected to the bulb. Okay, to the lamp. Sorry, to the lamp. Okay, same thing for How Ray. You also mentioned that there will be still current flowing through. That is incorrect. When the switch is open, there will be no current flowing through. Okay, why do I put the switch in the live wire? It's so that your table lamp will not be live. Is that clear? That is the main thing I want you to learn today. Okay, I've been reading your answer, How Ray's answer, as well as Yi Ting and Oscar. All of you tell me, when I put the switch in the neutral, there'll be current flowing through. That is incorrect. When there is a switch in the neutral, your bulb will be live. Okay, but there'll be no current flowing through. But if you put your switch in the live wire, your bulb will not be live. Is that clear? So can you please rewrite and then show me the answer now? Okay, Oscar, your answer for A is not wrong now, but there's no need to emphasize that there's no current flowing through. When the circuit is open, there'll be no current flowing through. So that's not the main point. The main point is your table lamp will not be live. That's all. Is that clear? Oscar, is that clear? Okay, now for part B1. What is the purpose of the fuse? Okay, I think this one, let me just give you the answer. It's a very straightforward question. You just need to know what the fuse is about. And this is a 3-mark question, so therefore you must write a bit more, okay? Okay, is that clear now? Okay, that's the purpose of the fields. Okay, please read about this. Okay, Oscar, I will give you the full 3 marks for part B1. Okay, but can you see the difference in the answer? There's slight things that you can improve further. Okay, so can you please look through and then can you see where's the part that you can improve? Okay, but your answer is not wrong, but you can actually improve. Okay, for Pei Kwan, this is a 3-mark question. Okay, it's a 3-mark question. If you write like this, I cannot give you 3 marks. Okay, so for this one, it's a 3-mark question. Ryan, I just praised you today. What happened today? You never, this question you never give me the answer. What happened to you? What happened, Ryan? Okay, let me continue. Let's look at part 2. Yeah, every lesson you'll be in the toilet one. Mr. Ryan, how come? You must go toilet during my lesson. Okay, everybody do part 2 now. Okay, so for part 2, it is a lesser mark. It's just 1 mark. Okay, so can you all do now? Okay, for part 2. Okay, Oscar, because it's 1 mark question, I'll give you the 1 mark. Ryan, what are you talking about? The earth wire is connected to the earth wire. Okay, so the question is why when a person who touched the case will feel nothing? Your case have some current, but why will you feel nothing? So what if it's connected to the earth wire? What's happening? How does the earth wire protect us? Okay, when we touch a metal casing that is connected to the loose wire. So the metal casing is actually live, for example. So why would our hand not get, okay, why would our hand not get shocked? Okay, because it's a 1 mark question, okay, most of you can get it correct, but can you explain to me why? Okay, so most of you can tell me wire C is the earth wire that is connected to the metal case. But how does this protect users from not getting an electric shock? Okay, are you able to explain to me why? Okay, so there's a loose wire touching metal case. So the metal case actually has some potential. Okay, so when you touch the metal case, why don't you get shocked? Do you know why? Okay, let me explain to you why. Let me explain to you why. Okay, this I did not explain clearly in the past. So let me explain. So when wire A becomes loose and touches the metal case, correct? What happened? The current will flow through the wire C, which is your earth wire. Okay, it will flow through your earth wire C. Okay, why will it flow through the wire C and not to you? Okay, and not to you. Okay, because wire C has a lower resistance compared to the person touching the case. Clear? Okay, so the wire C, which is earth wire, has a lower resistance. So the current will flow through the wire C rather than flowing through you. So if there is no earth wire, and then your metal casing has a certain potential, when you touch it, the current has nowhere to go except through you. Is that clear? But because there's an earth wire which has a very low resistance compared to you, the current will flow through the wire C into earth rather than flowing through the person. Are you clear about this concept now? If you are clear, give me a yes reaction. If you are clear, give me a yes reaction. Okay, Pei Kwan, how are you okay? Howry, are you there? Okay, let's do 4 more marks of question. All right. Okay, so you are clear already. Let's carry on the last page. Then next week you continue the rest. Okay, the lamp is marked like this. So can you calculate the resistance of the lamp? Then the second lamp is marked like this. Can you find the ratio? Okay, do these two questions. Then do the last one. Okay, that will be the last for today. If you can do this correctly, I call your name, you may leave. Okay, so this is the last exit question. Do these three questions correctly, I call your name, and you may leave the lesson. Hooray, part one correct. Oscar, part one correct. Why got no working one? 2 marks there. Ryan, part one correct. Hooray, your part two is correct. Qiao Xing, your part one is correct. Hey, can you all finish ready? Type all your answer in one answer, then I can monitor. You all give me part by part. There's 6 of you. I will sure get confused one. So once you are done with the 3 questions, type out everything in one statement. Oscar, your part 2 is incorrect. Try again. Okay, Qiao Xing, your part 1 is correct. Ryan, your part 2 is correct. Very good. So can you give me the whole answer in one answer so I can monitor easier? Okay, Oscar, part 2, try again. If you need help, let me know. Okay, Yuting, you got all 3 correct. If you have nothing for me, you may leave. Okay, Hooray, can you give me all the answer together? Okay, Ryan, well done. You may go. Okay, hooray. Hooray, your answers is correct. You may go. Okay, Qiao Xing, your part 1 is correct. Part 2. Are you able to simplify your answer for part 2? And then it is asking you the ratio between the resistance of the first lamp and the resistance of the second lamp. Okay, Qiao Xing. Okay, how to do this question? Okay, you know that R1 is equal to V1 over P1, correct? Okay, Peiguan, same thing for part 2. I want you to listen to me. R2 is equal to V2 square over P2. Is that okay? So you want to find the resistance P R1 over R2. What do I get? So I'll get V1 square over P1 divided by V2 square over P2. Am I right to say that? And because their V are the same, can I cancel this V? So P2 over P1 okay, so can I get P2 over P1 to be 60 over 100, and therefore your ratio is 3:5. Are you clear about this? Okay, for Qiao Xing and Peiguan, you understand now? Okay, you all are not able to simplify is because you are using a not exact answer. Okay, so because the V are the same for both, if I were to simplify, the ratio of the resistance is actually the ratio of the power, opposite power lah, P2 or P1. Okay, so therefore your answer will be 3:5. You all clear about this? Okay, for Peiguan as well as Qiao Xing. Understand now? So Peiguan, you give me the correct answer at first. Then after that, you after you do your working, then become wrong. What happened to you? Your answer come from where? You tell me. Okay, Peiguan, your part 3 is incorrect. Try again. Let me read Qiao Xing's part 3 answer. Okay, double insulation is not that the wire is insulated doubly. It basically means your device has double insulation. So it's not made of metal casing. Okay, it's just that the surrounding, the casing of the lamp has double insulator. It's not the wire have a double insulator. Is that clear, Qiao Xing? So let me explain the last part to you all before I let you all go. Okay, the last part you all need to explain like this. Okay, so the casing is no longer metal. The casing of the second lamp is made of an insulator. Okay, thus even if the live wire breaks and touches the casing, no current will be able to flow in the casing. Is that clear? Thus, even if a person touches it, he will not get an electric shock. Are you clear about this? Okay, so the casing itself is not metal, it is already an insulator. So when your wire inside were to break and touch, it will also not, okay, it will also not, okay, it will also not, okay, make you having an electrical shock. Okay, so can you type this out now? Once I see your answer, okay, I call your name, you may leave. Okay, Pei Kwan, you must mention that the casing is not made of metal, it's made of an insulator. And Oscar, your part 2 is not correct. It is not 53:88. Can you redo? Okay, if you cancel off the V1 and V2, you should get 3:5. Okay, Oscar, your part 3, your part D, I also will not give you the answer, the marks. Can you rewrite again? So, Pei Kwan, what's your answer for part 2? C, part 2? Okay. Everybody understand this question now? If you're okay, give me a clap reaction. Oscar, you okay? All right, thank you so much. You all may go. Okay, I'll see you again next week. Take care. Good night. Goodbye.